Sequences in series, arithmetic sequences, type 3, finding an unknown. So we're going to look at two examples here where we're finding an unknown, and we'll have two different approaches for the information provided. So the first example here, we have the first three terms in an arithmetic sequence. So we would underline that these are the first three terms, and we would underline that they are in arithmetic sequence. And we have to find the value of k, and then we also have to write down the first three terms. So above the three terms, we're going to write T1, T2, and T3. And the fact that they're in arithmetic sequence implies that there is a common difference. So because it implies there is a common difference, we know that T2 minus T1 must equal T3 minus T2. So we're going to use that to help us find our unknown. So we'll have 2k plus 3 minus k plus 2 is equal to 5k minus 2 minus 2k plus 3. So if we get rid of our brackets and simplify, we're just going to end up with a linear equation here. So we'll have 2k plus 3 minus k minus 2 equals 5k minus 2 minus 2k minus 3. So on the left, we're going to have k plus 1, and on the right, we're going to have 3k minus 5. So bringing everything to one side, that gives us 2k is equal to 6, and therefore k is equal to 3. So if we then want to find the first three terms, all we need to do is sub in for k. So T1 is k plus 2. So that's going to be 3 plus 2, which is equal to 5. T2, the second term, is 2k plus 3. So that's going to be 2 times 3 plus 3. So that's going to be 9. And then term 3 is 5k minus 2. So that's 5 times 3 minus 2, which gives us 13. So in other words, the first three terms are 5, 9, and 13. So in the second example here, again we're told in an arithmetic sequence, the fifth term is 19, and the eighth term is 31. And we want to find A and D, the first term, and the common difference. So the fact that it's an arithmetic sequence and we're given T5 and T8 means we're going to have to use our general term, A plus n minus 1 times D, to set up two equations, which means we're going to use simultaneous equations to solve here. And again, our general term formula can be found on page 22, where we're looking at the general term for arithmetic sequences. Okay, so if we have T5 is equal to 19, what that implies is that n is 5. So therefore that means we have A plus n minus 1 times D is equal to 19. And if I tidy that up, that's A plus 4D equals 19 is my first equation. If we have the second piece of information, T8 is equal to 31, well, that implies that n is equal to 8. So if we sub in again for n, we will get a second equation in terms of A and D. In other words, A plus 7D is equal to 31. So now we have two equations in terms of A and D. So if I put them side by side, we have A plus 4D equals 19. And we have A plus 7D is equal to 31. So if I multiply the second equation by minus 1, we'll be able to eliminate A. So we have A plus 4D equals 19, minus A minus 7D minus 31. And therefore I have a minus a. And we have 4d minus 7d is minus 3d. And we have 19 minus 31 is equal to minus 12. And therefore d must equal 4. So now I know my common difference. I sub d back into a. Sorry, d into 1 I should say there. And therefore that gives me a plus 4 times 4 is equal to 19. So a minus 16 is 3. Or sorry, 19 minus 16 is 3. So in other words, our first term is 3 and our common difference is 4. And sometimes they ask for the first 3 terms. So if they were to ask for the first 3 terms, we could start by saying, well, a is 3, common difference is 4. So if I add 4 to 3, I get 7. And if I add 4 to 7, I get 11. So you can write down as many terms as you want with that information. So on page 203 in your books, you're going to do question 16. And then on the sheet attached in Teams there, you're going to do question 6, 7, 8, and 11. And then you can come back and write down the next type, which is type 4. So for type 4, we're looking at 3 consecutive terms. In these questions, we're not actually told what the terms are, or we're not given them in terms of any letters. So if we have 3 consecutive terms in a sequence that's arithmetic, we know that the first term is a, the next term is a plus d, and the next term is a plus 2d. In other words, if I keep adding d, I'll get to the next term once it's arithmetic. But if we're using this to solve for our 3 consecutive terms, it can get a little bit messy. So what we always tend to do in these questions to make life easier for ourselves is we let the 3 consecutive terms be a minus d, a, and a plus d. So in other words, we're still doing the same thing. We're still adding d to every term. But if I go to add these 3 terms together, what you'll notice is the d's will actually cancel, and straight away we are going to be able to solve for a. Where if we write it down as a plus d, and a plus 2d, well, if I add these 3 terms together, we're going to get 3a plus 3d. So we're getting to more complex and messy equations. So it is better to let our 3 consecutive terms be a minus d, a, and a plus d. So I'm going to remove this line here so as not to cause confusion. Okay, so let's look at an example. Okay, so in the example we're told that the sum of 3 numbers is 18 and the sum of their squares is 206. So we have the sum of 3 numbers is 18 and the sum of their squares is 206. And we're to find the 3 consecutive terms given that the sequence is arithmetic. So the fact that it's arithmetic, we start by saying, let the 3 terms be a minus d, a, and a plus d. So that means if I look at their sum means if I add the 3 terms, so a minus d plus a plus d, then their sum we know is 18. So that gives me 3a is equal to 18, and therefore a is 6. So a is 6. So if a is 6, I can use that information then for the second equation, which is the sum of their squares. So we say sum of squares. So that means that I must take each term, a minus d, and I must square it. And then I'm going to add it on to the next term squared, which is a squared, and the next term squared. And they will all add to give me 206. So we have a squared minus 2ad plus d squared plus a squared plus a squared plus 2ad plus d squared equals 206. So if I simplify that, I have 3a squared, 2ad and 2ad is gone, and then I'm left with 2d squared, and that's equal to 206. But I know that a is equal to 6, we've just established that. So that means that I can put in for a, so 3 times 6 squared plus 2d squared equals 206. So 6 times itself is 36, and 36 times 3 is 108, plus 2d squared is equal to 206. So 2d squared is equal to 98, d squared is equal to 49, and if I get the square root of 49, I get plus or minus 7. So again, we have to be careful there. Getting the square root of the number, it has to be plus or minus 7. So now we know that a is 6, and we know that the common difference can either be plus 7 or minus 7. So therefore we can say the 3 terms. And again, be careful. We said our first term was a minus d. So the 3 terms are going to be a minus d. So if d is equal to 7, we'll start with that. Then a minus d is 6 minus 7, 6, and 6 plus 7. So that gives me minus 1, 6, or 13. And if d is minus 7, then that means the first term was minus 7, 6 minus 7, 6, and 6 minus 7. So that gives me 6 plus 7, which is 13, 6, and minus 1. So what you see is we actually get the same numbers, just in reverse order. So the 2 questions you're going to do based on this are find 3 consecutive terms of an arithmetic sequence if their sum is 3 and their product is minus 15. And the answer is given there for you, so you can check. And then the question 2, 3 consecutive numbers in an arithmetic sequence have a sum of 24 and a product of 494. What are the 3 numbers?